I am recording now. Okay, and recording audio. Okay. So let's start then. As I said, exam February 15th. Don't forget. And also this week we're doing TCP session hijacking. All right, so let's start with TCP session hijacking. Let's kind of go to Brightspace over here. Let me share that. And let's motivate with the lab. Okay. So you can see here, let's go to content. Okay. And we are in this module here, TCP session hijacking. So this should be one of the most fun labs. They're all fun, but this is a fun one for sure. There's basically 3 tasks that I'm going to ask you guys to do. One is, as I said, to send a command to the server. I'll explain that in more detail, but initially you're just going to send a command. Then after that, I'm going to ask you to steal a file, right, and send it back to yourself. So we're going to be doing a lot of tunneling. So one of the common themes in this class this semester is tunnels, right? So we use tunnels for a lot of things, to evade security and also to, attack, I guess, or do bad things. Okay, so and then the last one will be to do a reverse shell, which is basically, kind of the holy grail, right, of attacks, where you want to steal a terminal, hopefully with the root privilege, and take over a machine. Okay, so recording. So then let's go ahead and just look at the documents that I've posted in here first. So as you can see, I have, this is just to set the commands. So I'll start with this one, I guess. This is just the netwalks command. So most of these labs actually, I think, can be done with Python. So they should be pretty much easier, but you have the netwalks option. And these are just for the TCP session hijacking, it takes netwalks 40, and is basically you type these 2 commands, okay? And then you just have to get some of the parameters correct. We'll talk about that and why today. Notice that one sends data over here, right? And then the other one is just like an acknowledgement packet. So that's basically the idea. You shoot the data and then you kind of acknowledge it. And then that kind of completes the connection, the TCP connection. And so the machine will, act after it receives those 2 packets. All right, but this is just the netwalks approach. We'll come back to it. Just be aware I have posted those there. Okay, and then here I have 2 documents. This is probably just my notes, I think. Yeah, you can see these are just some of the notes that I'll do today. You can reference them for your own. Okay, and then of course, let's start with motivating with the PDF. Okay, so we'll be doing, we've been working through this one, right, for a couple of weeks, I think. So TCP IP attacks, so I've talked about these already. And we've done SYN flooding and reset. Now we're basically just focusing on these 2 right here. Okay, so we're focusing on those 2. Of the document. So, I'm not going to repeat all of this, so you can just read through it. And then let's just kind of find TCP session hijacking. So there it is. Okay. So the objective of TCP session hijacking attacks is, as the name implies, to hijack an existing TCP connection, a session between 2 victims, by injecting malicious contents into this session. All right, so remember, it's exactly like this diagram. So it's exactly like this diagram over here, where you have a client and a server, and you have an established communication, right? This could be Telnet, this could be SSH. The problem with SSH is that would be an encrypted connection, right? So even though some of the headers do have fields, the plain text fields, the data itself is encrypted. So what's the point, right? Because you might send a packet and the packet gets there, but the data will be gibberish. because you don't have the key, right? And the key has randomized as much as possible the data, so it's encrypted. So you wouldn't be able to deliver payload, but that's basically the idea. Okay, so we'll use these examples. We'll motivate how this works via telnet, of course, because that will give us actual outputs. But keep in mind, these attacks can always be modified, right, in some way if somebody finds a vulnerability to exploit them. But basically, the scenario is you need a client machine and a server machine, and then you need an attacker machine. And then imagine this is the telnet client, this is a telnet server, they have an established connection. Now the attacker needs to spoof packets. We've already been doing that all semester, right? How to spoof packets. And so now we just need to throw a spoof packet into the network and convince the server that it came from the client. Do you guys see that? So that's generally a pretty simple idea. So the objective of the TCP session hijack attack is to hijack an existing TCP connection between two victims by injecting malicious contents. If this connection is a telnet session, attackers can inject malicious commands. And then those are the things that we're going to do today. We're going to run ls, steal a file, and do a reverse shell. So this can cause the victims to execute the malicious commands. And then we can see here, figure 3 depicts how the attack works, basically. So in this task, you need to demonstrate how you can hijack a telnet session between two computers. Our goal will be to get the telnet server to run a malicious command from you. And we're going to assume, of course, that they're in the same LAN and everything. So launching the attack manually, we'll use SCAPI to conduct a TCP session hijack attack. And this is the skeleton code. So I'll go through this in more detail in the demo when I turn on the virtual machine. All right, you need to, and then you'll need to replace some of these. So I'll talk a little bit about what defines a session as well, more formally. Of course, as always, you should have Wireshark running in the background. That will give you a lot of help to look at the values. You also know that you can sniff and spoof the data, which means you can grab packets and invert them and send them out. So that's also an alternative that we have seen before. So as you can see here, that's this part, launching the attack automatically. Students are encouraged to write a program to launch the attack automatically using the sniffing and spoofing technique. Unlike the manual approach, we get all the parameters from sniff packets, so the entire attack is automated. Okay, now I want you guys to do it in both ways. Okay, just definitely it's useful, right, to go through the trial and error. Remember, filtering is extremely important here. It's telnet packets is really what you want to look at. Okay. What was week 8's question 8? What was question 8? Which lab are you talking about, Urusa? What is lab 3? Is it the TCP resets? The multimedia, do you mean maybe? Urusa, which one do you mean? All right, just remind me at the end of the lecture then, okay? So think about it a little bit. All right. So as I was saying, please do both manual and also sniff and spoof. It's kind of it's actually very helpful to figure out the sequence numbers there. So we'll do this for, as I said, 3 things. We will steal a file, launch a ls command or pwd, and also do the reverse shell using TCP session hijacking. So let's finish this document, I guess. So, but I'll specify later that I want those 3 problems done. So creating a reverse shell using TCP session hijacking. So when attackers are able to inject a command to the victim's machine using TCP session hijacking, they are not interested in just running one simple command on the victim machine. They are interested in running many commands. And that's kind of the idea. So In the first exercise, problem 1, you just insert ls or pwd, but you actually don't get anything out of it, right? As the attacker, all that can happen is the server will reply to the client, because initially you're pretending to be the client. So who is the server going to reply to but the client, right? So that doesn't work, but we're still going to do it. However, this is saying that you actually want to do something, right? To take over the machine. So they are interested in running commands. It's a CC++. Okay. Oh, it's the ping 1234. CC. Okay. Yeah, so we can do that. Just remind me at the end. That's fine. Okay. Yeah. All right. All right. So as I was saying, so running these commands all through TCP session hijacking is inconvenient. What attackers want is to achieve is to use the attack to set up a backdoor so they can use this backdoor to conveniently further damages. A typical way to set up backdoors is to run a reverse shell from the victim machine to give the attack shell access to the victim machine. Give the attack, yeah. So reverse shell is a shell process basically running on a remote machine, connecting back to the attacker's computer. So as I said, we're going to be doing a lot of this tunneling this semester. This gives an attacker a convenient way to access a remote machine once it has been compromised. Obviously, what that means is simply your payload. Okay, it's going to be different now. So the three problems are very similar in terms of what you put in to impersonate the session, but then the payload is going to change in each one. Okay. So in the following, we will show how we can set up a reverse shell if we can directly run a command on the victim machine, in this case, the server machine. In the TCP session hijack attack, attackers cannot directly run a command on the victim machine. So their job is to run a reverse shell command through the session hijack attack. This way, they run the code or the command in the server will connect back to some other location. So you guys, the students, will have to achieve this goal. To have a bash shell on a remote machine connect back to an attacker's machine, an attacker needs a process waiting for some connection on a given port, right? So that makes sense. In this example, you can use netcat, which is a nice tool for piping, for creating tunnels. This program allows us to specify a port number and can listen for a connection on that port, right? And you can see here basically the list of commands. So in the following demo, we show two windows. Each one is from different machines. And then the top window is the attack machine, 10901, right? You can see here, netcat listen on port 9090, right? It's just waiting for the connection. Do you understand? Yeah. And then, so the top window is the attack machine, 10901, which runs netcat, netnc for short, listening on port 9090. The bottom window is the victim machine, 10905. And basically, and we type the reverse shell command. So if you guys go into a server and you type that command, and then you have another machine that's already listening, you're going to have a connection. Do you guys see that? So it basically makes it the connection. Our job is to insert this command here, but through the session hijacking attack. So in the spoof packet that we sent, the payload needs to look like that. Got it? So that will be the idea. That's really all that's changing in all three problems. So the bottom window is the victim machine, 10905. And first I would recommend actually that you just take your two VMs or two VMs and just manually type these commands. Make sure that you can actually establish the reverse shell manually, if you will. And then you'll know, okay, it works. I can control one machine from the other just by running these. Then after that, you'll run the attack, and it should also work Any questions about this so far? Okay. As soon as the reverse shell gets executed, the top window indicates that we get a shell, and you get something like that. Okay, and then that basically works. All right, here's a brief description. This will be very useful to you. You probably remember these things for 372, right? We covered all this in 372. So you should already know it. We provide a brief description on the reverse shell command in the following. So bin bash, you can see that here, I stands for interactive, meaning that the shell must be interactive, must provide a shell prompt. So we'll run that command. Then these symbols, if you remember, these were redirection. So we redirect to dev, which remember that's just a dev folder where you have your devices, and then you create devices like TCP devices listening on specific port. So this causes the output, standard out, of the shell to be redirected to the TCP window, sorry, TCP connection 10901 on port 9090. And then the output standard out is represented by the file descriptor number 1. Okay, that, right? You probably remember that as well. Okay, and then we have the file descriptor 0 represents the standard input in. Okay, this causes the standard in for the shell to be obtained from the TCP connection. This is so that we can do back and forth, right? So remember, we send, but we also receive, so we can get both of them working. And then file descriptor 2 represents the standard error. If you remember, we also covered that. This causes the error output to be redirected to the TCP connection. Basically, the command is correct. I mean, at the end of the day, you can just plug it in or type it up. In summary, this command starts a bash shell with its input coming from a TCP connection and its standard and error outputs being redirected to the same TCP connection. All right, so that's basically it. I'll show you the demo in a sec. Okay, all right, so any questions so far about this? I'm not seeing any questions here. All right, so let's talk a little bit, just a few notes on TCP in general, and then we'll do the demo. Okay, so TCP session, and you guys know about. Oh, yeah. Let me move to the whiteboard. So basically, there's in TCP connection, there's the three-way handshake, right? That happens first, and then after that, there's the exchange of data. Okay, so once a TCP client and server finish the three-way handshake, okay, or the handshake protocol, a connection is established, and we call that a TCP session. So that's where that is coming from. It's called a TCP session. Okay, now this session has to be defined by something, right? So from then on, both ends can send data to each other. Since a computer can have multiple concurrent TCP connections, right, there's got to be a way to differentiate them, right? So with other computers, when it receives a packet, it needs to know which TCP session the packet belongs to. So what do you guys think? How does it define the TCP session? What would you say? How are they defined? Is there some kind of a private key or public key, or is there some kind of a, how would you define it? To define this session? Remember, it's client and server did the three-way handshake, right? There's an established connection. What is an established connection? Does that mean that there's an actual tunnel that was built? No, right? Every packet that goes in some crazy way, different directions, has to have something that defines that session. Each one of these is a session. Yeah, go ahead. Well, those are protocols, but I just mean, you know, this is client 1, this is client 2. Think about that one, right? But they are connecting to Telnet on this end, right? Yes, sir. So, well, here you're talking more about the application layer, right? When you say that, caching and websites and things like that. We're not talking about the application layer and the OSI model. We're a little bit further down, right? TCP IP, that level of the OSI model. Does that make sense? So then what do you think you would use? You know, let's say you're building this protocol and you have all of these, right? Now, Telnet is not encrypted, but it still needs to be a session, right? It's any TCP does the three-way handshake. You guys remember what that is, correct? Yeah, an exchange of packets. All right. So then we have client 3, right? They're all connecting to Telnet. What is the Telnet port number? 23, right? So there's 23 open, and they're all connecting to that. But how does the server know that it came from client 1, client 2, client 3? There, it has some table of established connections, right? What are these? What defines this session over here, in your opinion? What would you guys think? So it's simpler than you think. The definition of it is a combination of
different clients connected to the same server.
Well, it's basically the session. You know, this is session, you know, 1. This is session 2. How does the server know? Right. So, a login application layer. OSI mod. So do you guys remember the OSI model, correct? Of networking. So there's things at the application layer, but we're not going that far. We're somewhere around here, correct? Yeah, somewhere around there. So it's the protocol just for that. It's like the protocol that will carry the application layer things, right? So TLS, which is the encryption, for instance, maybe up here, right? But we're not concerned with encryption right now. We're only concerned with the TCP connection. So what you guys want to do is you want to impersonate. So that your attacker over here. What does attacker want to do? They want you to think that you have session 1, or let's say session 2, just for. Do you see that? If attacker can say I'm session 2, server thinks it's coming from client 2, but actually it came from attacker. So that's the trick. So what defines a session? So the question is, since a computer can have multiple concurrent TCP sessions with other computers, when it receives a packet, it needs to know which TCP session the packet belongs to. So the TCP protocol at the OSI level here, right, uses 4 elements to make a decision, to uniquely identify a session. Yes, sir. Yeah, that a combination of 4 things, right? So what could these 4 things be? I already said it's the source IP, destination IP, yeah. Destination port and the source port. Exactly. That's actually, it is as simple as that, because that kind of makes sense. These 3 are on the internet. They have different IPs, right? They're all connecting to 23, but they all have one of 65,000 port numbers here, right? So that combination is going to be unique for the connection of the server. And that's really all it is, and nothing more than that. Do you guys understand? Now, but that's not enough to trick the machine. There's one additional component that makes it actually very different. The sequence number. Yes, exactly. The sequence number, what is the sequence number for? Yes, exactly. It's putting together all the packets, right? And the sequence number is basically whenever the amount of data that you send That's how much you increment the sequence, right? And that's how you keep track of things. So the sequence number actually is really important. And that's actually the challenge. You might argue that this would be somewhat easy, right, to do, but getting that sequence number is actually not easy. Why? Because the sequence number is actually a pseudo-random number. And I believe it's 32 bits, if I remember correctly. Huh? It's a pseudo-random generator. It's a function in the protocol called a pseudo-random generator that generates these numbers. Pseudo-random. And then even so if you open Wireshark, for instance, if you don't adjust the settings, you might think the numbers are like 1, 3, 5, whatever. But those are only the relative numbers. If you actually toggle something in Wireshark, it'll show you the actual sequence number, and you will see it's a long number. And you will actually you'll play with that in this assignment, because that's the key for this to work. You'll have to get that sequence number correctly. You guys understand? You'll see it there, but as long as you have the sequence number, the attack will work. So you'll see that. All right, so let's take a. So we set that, right? So we call these 4 fields basically the signature of the TCP session. It basically defines that. As we have already learned, spoofing packets is not difficult, right? So you guys have seen that. You can do it actually. What if we spoof a TCP packet where we know these 4 parameters, right? Then you might think, okay, I have the session, I understand it. So, but this won't be accepted immediately, okay? So, yeah, so for a packet to be accepted, one more step needs to be, one critical condition needs to be satisfied, and that's basically what I said, the TCP sequence number. So as you know, TCP is a connection-oriented, unlike UDP, is a connection-oriented protocol, right? So there's this acknowledgement that you receive information and treats data as a stream. So each octet in the TCP session has a unique sequence number identifying its position in the stream, basically, okay? The TCP header will contain, as I said, these 32-bit sequence number fields, which contain the sequence number for the payload, basically. And then when the receiver gets a TCP packet, it places the TCP data payload in a buffer. Okay, so it's going to place it in a buffer where exactly, yeah, go ahead. Oh, no. I was going to draw something, but I was just reading this part. So basically, if we go over here, we can think of the buffer is kind of like this, right? And then it receives a packet. So you might be at, it ends at X, right? The data that you've received so far. And then it's going to tell you when you receive data where the next one goes, right? Which is here. Right? And that's basically it. But that's the problem with an attacker. The data will not be delivered to the system until everything is complete. You guys see that? And so that's the problem, because the attacker, if they need to guess exactly that to fill in that gap, right? If let's say that they are trying to guess and they just do something like delta, I don't know, data, right? So, that may come offset here or too far away. They don't really know where the sequence number is, right? So it might be very difficult for them to guess. And so the trick is that they have to have the exact sequence number in order for this to take effect. Do you guys see that? Even if they miss like a little gap, it's not going to go. And then eventually, keep in mind, the real packet may arrive, because keep in mind that there is a connection between 2 machines that are exchanging data. right? So this is a very fast thing that needs to happen, and the real data may arrive. So maybe the attacker puts his or her data here, but that didn't work. And then the real data comes in, completes it, and it just it just ignores whatever they had written. Does that make sense? So that's the key concept, and that's a difficult task actually, because as you know, a 32-bit pseudo-random number, guessing that is difficult. Okay, and so the best thing that you can do is with sniff and spoof, you actually, like what you're doing with Wireshark also, right? With Telnet, it's really nice. This would be difficult also with like multimedia, right? It makes it more difficult then. But with Telnet, you type something and it's just waiting there. You know that, right? So it's just kind of hanging there. So then you can go in and just, the packet stop basically. So you just grab the last packet, grab the numbers from that, and then plug it into your attack, and you should be good. You guys see that? And then with the sniff and spoof, that should, because we're for all three problems, we're going to be using Telnet. So sniff and spoof will also work. Basically, it'll just grab the last packet and send it out. Is this clear, guys, this idea? That's it. I mean, that's the general information. Everything else is just kind of the logistics of how we're going to do this. So, you know, reverse shell and all that is just the commands. So let's take a look at solving it, and then we might come back if you're missing any additional information. So everyone, those of you virtually, are there any questions about this? Anything you don't understand?
So just to clarify, the sequence number is does it increment?
Yes, it's going
as
to
the session continues.
As the data continues. So for instance, let me do I guess that's a good question. So let's take a look at a little example of that. So let's do the following. Let's do the TCP three-way handshake first. Okay. Let's do the TCP three-way handshake. All right. So you guys know what the three-way handshake is, right? So you have a client, because we did actually the denial of service attack, right? So, you know, sends a packet, sends a confirmation, an acknowledgement, and then finally the connection is established, right? This happens in 3 packets, right? And then that, now you have a session between those created. So when you do that, what happens to the sequence number? So let's say we have the three-way handshake. Just that part. We're not exchanging data yet, okay? So let's actually say no data. So these packets, you know, they might carry like 1 byte or something, right? But not much. So think of it from the side of the client. And then think of it from the side of the server. You know, this would be the Telnet server and the Telnet client. So here obviously is port 23. And then here, let's say is, or, you know, yeah, 23 is fine. And then here, let's say it's port, some port like 54,841, right? So out of 65 ports. So then we're going to start over here. Let's say client 54,841, and then the server port 80. You send the first packet, right? This is the SYN packet. Yeah. Send the SYN packet. And then the SYN packet probably will have a sequence number of 0, right? Relative. This is relative. Okay. I don't know the actual, because it would be a pseudo-random, really large number. But relatively speaking, it's going to be 0. Does that make sense so far? Okay.
Yes.
Okay. And then ACK number, there's nothing here because it just started, so it's probably null or something like that. Okay. Then you have what happens next, right? So now you still have port 80, but now in the other direction, the server is going to send, you know, the SYN ACK, the SYN ACK packet. Okay, now it's going to say, well, from my direction, this is another direction, right? Not the original one. is sequence, and I'm going to act your 1 plus 1. You know, something happened there and it incremented by 1. You see that? So basically it's doing that. And then finally, 54841 is going to send back to port 80 the ACK, the final ACK. This is what completes the connection, right? This is the three-way handshake. And then here, basically now the sequence number, because it was ACK to be 1, so it's now 1. And then this is going to be also ACK 1 for the other one. You guys see that? And that's it. That's basically what happens to the sequence numbers, but that's in the three-way handshake. That's not where you want to do the attack, correct? Because you want to take over an established connection and impersonate them. So now we saw this behavior. Now let's take a look at the behavior. Let's say a connection has been established, and now we're going to do the exchange with data. All right, so let's take a look at that one over here. Okay, so let's call this one established connection. Established connection, right? And here now we're going to send, now we send data. Okay, so again, let's think about the same connection. So we have our client over here, and then we have the server over here, right? Still telnet. So then I think it was port 23 that we said. Port 80. Sorry about that. Yeah, sorry about that. Yeah, so we were talking about telnet, but 80 would apply. This is all TCP. Yeah. All right, and then we continue with the 54841 just to continue with this exercise. All right, so now you have an established connection. Let's say that the client here wants to send 725 bytes of data. Right, just let's say that that's what's going to be sent for whatever reason, or it could be maybe HTTP would send a lot more data than that. So now we're going to send the data, right? So what needs to happen is there's going to be a push and an ACK flags in the packet because we're pushing data. The length of the data, we can specify it to be about 725. Right, so now let's say you receive, this was the first, so then the sequence would be 1, the ACK is 1, right? But now from this direction, the sequence numbers are going to change. So now this is going to, two things are going to, one thing that needs to happen here is first, this needs to be ACK, right? You need to ACK that you receive that data, okay? And in that ACK, you will say sequence number 1, but ACK 726. Do you guys see that? That's the increment that's going to happen because the next sequence number needs to reflect that you've already sent that amount of data, right? That's how it keeps track. That's what I was saying about the buffer. It needs to be precise so that it can re-put it together. So that happens here, right? Additionally, to make it more interesting, let's say that the server sends data because you type that you wanted ls-l, and ls-l is actually a whole bunch of files, right? So you're actually going to send data in this direction. So there's another then transmission here where you're going to send now the length of the data is going to be, let's say, 1,448 bytes of data that you're sending now. So this is also sequence 1, but this is ACK 726, right? So you're just, because that in your other direction is that you're sending the data for 40. So one is going from client to server, that's one thing. One is going from server to client, that's another thing, so that they can put together their own respective datas, right? And then finally over here, you can see 54841, maybe that's all that 54841 wanted. So they're not going to send any data back, but they still need to act that they receive that data, right? So then here it's going to be now the sequence number is now set to 726, because here, if they were sending more data, that's where it should start now, right? And they're going to act also the next number for you, which should be 1449. So 1448 plus 1. Do you guys see that? So this is the way the sequence numbers are going to be incremented relative to the amount of data that's being sent. And then you need to piece together this. Yes. You have to go out of your way. What do you mean by that? The date. So, oh, I think I understand what you're asking. Yeah. So what you're asking is this. Think of it probably like this. So you're asking, I think, that there's data like this, and then it's expecting some data, the good data. But then the attacker sends their bad data. And as long as it kind of is flush there, if you will, it'll accept it. And it'll execute then your command. Do you see that? What might happen is that later this block arrives, and then the system's going to get confused. And it might start, you'll see probably in your attacks that there's going to be like, hey, something happened, something is wrong. But the problem is this already executed. Do you see how that works? So that's why, what does that tell you? It tells you, I just need to get the sequence number, the correct sequence number, the right one. As long as I complete that, I will be good. Is this clear for everyone, guys? Are there any doubts or questions? This is fundamental for you to do this correctly. Okay. It's the hardest part. Yeah, go ahead, somebody.
So, yeah, so when I was going through the textbook, it said that you have to kind of estimate the next sequence number like you demonstrated, and you have to estimate high. Is there any particular way, I guess, to accurately estimate the sequence number?
You can simply just get it from Wireshark because we're using Telnet. And so the connection will have stopped, right? Like you can type a command like ls or pwd, and it'll just be there. So just by looking at the last packet, you can take that, and then sniff and spoof will actually just take those values. So you don't really have to do anything very complex.
Okay, thank you.
Any other questions, guys? So it makes sense? All right, so yeah, so the idea is, if you think about it, honestly, as long as you look, because it kind of, another thing that happens is it's kind of telling you what's the next number, right? It actually almost tells you that. Hey, you're actually, Wireshark does that. It'll say, hey, by the way, your next sequence number is this. They actually go to the trouble of telling you. So then you can play with, but the basic idea is this, right? So hopefully you understand that you were at one sequence number, you sent 725, so the next sequence number would need to be 726, the next one. So if you guess that number, you'd be able to insert your command in there. Any other questions? All right, sounds like there are no questions. So we completed this exercise, we did the example. So now I think we can go ahead and take a look at the problems and see if we can solve them or get started with it. So let's go ahead. All right, so we'll start. Remember, we're going to do 3 problems. Okay, so we'll do. All right. Okay, so let's start the virtual machine. I'll go ahead, stop sharing this one. And everything that we did today, by the way, is in those notes that I posted. So you can just use that. So let's start the VM. Cool. Let me share this. Share screen. So you should be seeing the virtual machine now. All right, so there we are. So let's go ahead, go to the folder. Probably open up Wireshark also. Helmet. So remember, this is what I would recommend, the filter that you use just for telnet packets. Also turn off like your browser, etc., so you don't have too much traffic there. Yeah. In the code, you mean? So what filter do you use in the code? 423. Okay. All right. Yeah, that's a good one. Yeah, that's. Mm-hmm. Okay, so port 23 is probably, yeah, better filter. Okay, good one. All right, so yeah, so this is what we're gonna do. Now we're gonna think of the first scenario, right? So in the first scenario, I actually need to go to, so these are the three problems that I want you guys to work on. Okay, first problem, let me just go here. First problem. Right, we will have, so you will establish a client and a server. And this is going to be telnet, right? So this is problem one that you need to solve for the homework. All right, so telnet. So first, establish a connection between the two machines, right? Figure out their IPs, the port numbers, find them. Then after that, the attacker will need to spoof a packet, insert it, right? And pretend to be the client. This packet, the payload of it should be a command. So for instance, the command could be ls. The command could be probably pwd is a better one. It's easier one because it's less data, right? The pwd is just the path where you are. So let's say that you ran this on home seed, right? So your home seed desktop. So when you are going to insert pwd in the attack, what's going to happen is, I'm going to use a different color here. Server will generate a packet response, but it's going to send it to client, not to attacker. You guys see that? And what is it going to contain? Well, if you go to the command line and you type pwd, it just gives you the path. So it'll say like home seed, right? Usually that's, if you're there, that's going to be the output. So what I need to see is some evidence that this actually generated. Now, this will not be, the attacker will not receive this command. This command is sent to the client. Therefore, maybe on the terminal here, on the terminal of client, you will need to see, I would, magically, let's say magically, home seed would appear. Do you guys understand? Yeah, go ahead. Yeah. Huh? No, you telnet from the client to the server first. That's the first thing you do. There's already an established telnet connection. Yeah, so step one, go to client, telnet into server. That's step one. Done. TCP three-way handshake has happened. There's a session. Second, go to attacker, and then from attacker, launch the attack with SCAPI, NetWalks, whatever you want to do. What do you need? You need to send one push packet, right? That has the PWD command as a payload. But that needs to have the parameters of the established session between client and server. Do you see that? And you can just use simply Wireshark for that. You don't have to make it too complex, but I want you to try both sniff and spoof and manual, right? Wireshark will guide you quite a bit. Then once you have that data, launching with NetWalks or SCAPI, you send out the packet. And then what should happen is that a packet is sent from server to client. And that's the response that will contain, as I said, the home seed. Because when you type on the terminal, so if I go to the terminal, right? Let me switch over to the terminal. PWD, home seed. You see that, what I'm talking about now? So I just typed this. So with if I was telnetted into the server, I would type that in on the server. The server would send me back home seed via the tunnel. But this time around, the attacker is inserting PWD. They should get home seed back. Or not they, but the server should generate that response. The only thing is, it's going to send it back to the client, not to the server. So what are two ways that you can corroborate that it worked? One is, of course, Wireshark. You can have Wireshark and look for a packet that contains home seed. You see that? That's definitely possible. But what I like for students to do, because it's more fulfilling, is to actually see it in client. And sometimes, remember, there's an attack, so the machines get a little, out of whack, if you will, right? And so what you have to do is you kind of have to like hit it with a bat. No. You have to just click on enter on the keyboard, and sometimes give it a little room, but eventually it might print it, so it will print it. And then you'll see a lot of, in the Wireshark output, you'll see a lot of like TCP retransmission or something. It'll complain because there's now two sequence numbers, right? It's something is off. If the attacker succeeded and then the machine, what happens is this. Think about it. It's actually quite interesting. The attacker sent something, client didn't send something. Client now receives a packet, and client is going to acknowledge something it wasn't expecting. You see that? And then there's going to be a conflict. So that's the first logic for the problem. Does this make sense, guys? All right, so let's take a look at how we would try to implement something like this. Okay, so we're going to go now to the virtual machine. So everyone should be seeing the VM. Okay. Clear here. All right, so obviously, get the information. Start Wireshark. I already did. See that there? It's got the filter. Okay. So one thing you can do is have Wireshark as you send the telnet connection. All right. So you're gonna do telnet. Let's say this is the client, right? So you would do 127.0.0.1, right? And you're gonna try to establish that connection. You look in Wireshark, you already have, obviously you should do this between two machines, right? But this is just the example. You can see it's trying to generate. Connection. Right, so that's the first thing. Establish the connection. Okay. Once you've established the connection, TCP three-way handshake should be complete. You can go into the machine and look at the different headers. Right, then the next thing you're going to do is you're going to try to insert the ls command or the pwd command. Either one should be fine. Okay. So to do that, we are going to create a script. So we're going to do a little script. Let's go ahead. Just going to navigate to my desktop. Okay. Let's call it TCP Session Hijack ls command. .py. Okay. So what we need here is these are pretty short, as you remember. So import scapi.all. Import scapi.all. Or sorry, from scapi.all import all. Okay. Then after that, we're going to send a spoof packet. So we all know that. Now this one assumes that you're just going to get the parameters from Wireshark. Okay. Remember, this is the first thing I want you to do. It's just for your own, convincing that this is how it works. We're going to send a packet. Right. You can say that we wanted to print some data. So verbose, or not print data, verbose 0. You can take a look at the structure of the packet just by doing lspkt. And then now here, we're going to build it out. All right. So we need, it's a packet. And it's going to be made up of the IP layer. And yeah, IP layer, then the TCP layer. Okay. And then this is what is going to be important, the data layer, right? So you need to figure this one out a little bit. So now here, for instance, we're going to do the IP layer. This establishes some of the parameters of the session. So IP layer. It's going to be IP, okay, like that. And then it's going to be source. So here, I'm just going to make up some IPs because this is dependent. So 192.168.182.129. Let's say, oops. Now that. And then the destination IP also. Destination, so that's going to be 192.168.182.131. Right, so you have your IPs there. Key things, the TCP layer. Okay. So this is TCP. And you have, what do you need? You need the source port and the destination port. So what should be the source port? That's right. You need to think in terms of the direction. Where is this going from? The attacker is pretending to be who? The client. So you have to think, okay, the client is going to the server. client is going to 23 from a random high port that was generated. So then here, the source port would be a high one. So I'm just going to put in 4622, something. It's just to kind of give you some reference. Destination port is port 23. Okay, because we know the direction. Then flags, right? You need to figure out which flag goes here. Okay, so play with that a little bit. And then here, you also want to play. So I'll just give you the keywords, but I'll leave, obviously, I mean, I can't even give you these numbers because these are random, right? So you'll have to figure out. What I can tell you is they're not strings, so these are integers. So these are integers. So I'll just write it, I'm gonna write a random number. Oops, sorry. Like that. Okay? Some random, you have to get that. And also try the ACK number. Try it with, without, and just get a feel for how it looks. Okay? You guys see this? So these numbers are what you will have to I kind of like the idea that you do this on a trial and error, right? So figure it out. But we know already that we have the things that define the session right there, right? And we just have to figure out the flags as well. Plug them in. Is this clear enough? All right. So now you pretend it to be that connection. The trick is now, let's say you've succeeded, but you still need to send the data that you want to submit, right? So that's going to be your data over here. Okay. And so you need to specify. Now this can get a little bit tricky, like if you need to escape characters or things like that. Now there's other things that you might want to consider, but it could be as simple as, what command did I say? PWD? PWD. What? I'm sorry. For the first problem is what I explained. It's a command, but remember, this command, to get the result, you have to go to the client. Well, in the terminal, I did it just to show that it works. Just to show that when I type PWD, it gives me home C, right? So when you launch this attack, I'll go to the diagram again. No. Yeah. Well, that's the whole point. Yeah. So let's say that this computer is like a financial computer, right? And I come here and I type PWD. When I type PWD, what happens? Money is transferred, right? But I have to be here on the terminal. You're the attacker. What do you want to do? You would love to, capture my brain, right, and make me type something that gives you the money, right? So then what do? You saw that all I do is I type PWD, and that makes you rich here. So then you create a packet and you send it, and that packet carries that PWD. The computer, when it arrives, it thinks that I typed it. So then it's going to do the thing it's supposed to do. But it sends the money to the bank. It doesn't send it back to you. You see that? So that's kind of what's happening here. The attacker sends the PWD packet, and there's a response with home seed that goes to client. But if I see in your report that you typed this, I'm not going to give you the points. You have to show evidence that you understand that. No. Is this clear, guys? All right. Now, other things to consider is we might be forgetting something, right? So let me go back. Oh yeah, we're at the terminal. So let me save this one. If I type PWD, just that, does it do it? No, right? What else is needed? Enter key. You see that? You also need that. You'll have to figure that out. So the ASCII characters for this, for the new line character, there may actually be 2. Okay? So I leave that to you guys to figure out, because it could be fun, but just keep in mind, if you just send this, look, you're not gonna get the result that you want. Okay? If you just do, you know, SSH, again, just sending the 3 letters does not accomplish. Yes, exactly. The packet needs to send both the command and hit enter. But that's just an ASCII character. Okay. So you just have to carriage return, right? So you just have to think what that might be. And then put it, you know, it's a ASCII character like any other, so put it there. Keep in mind that makes, so if you're sending 3 bytes, P, W, and D, that new line character is a 4th byte. Think of it as another letter. Okay, just be aware of that. You'll also notice that Telnet sends 1 letter at a time. You'll see that if you look at Wireshark. So is this clear, guys? Pretty easy. All right, so that's the scenario. So for the first problem, the LS one. So let's go clear over here. Were you guys on virtual seeing the VM? I don't know. All right, so
I was seeing it. No, now I do.
yeah, you guys didn't see all of that. Huh? Yeah, sorry about that. Yeah. Anyway, but like I said, yeah, I was just talking. What I said is just typing PWD like this is not enough. Notice that you have to hit enter for something to happen. Yeah. So, but all I was saying is this, right? I'll go back to the code in a second, but again, this is important. If you just send PWD, nothing happens. You have to hit enter. So what I'm saying is that translates in the code that there might be an additional letter that's needed. Okay? So just, you'll have to figure that out. How do you trigger that enter? Is that clear for everyone? Right, so I assume they get it. Okay, so that's basically the first example. Okay, so that's the ls command. Then the next one will be what? Probably stealing something or sending something, stealing a file, right? So let's take, and basically they don't change that much. It's just a payload that's going to change here. So let's move on to the next problem. All right, so let's go back. So in summary, basically, we go back to the whiteboard now. Problem 1 is send PWD or LS. I need to see a screenshot that was actually generated. That's very important, right? By stealing it. Okay, now problem number 2, similar. Problem number 2, you have the client, the server. You have, again, an established connection. You have an attacker. The attacker is going to send a packet, spoof packet, pretending to be client again in a very similar fashion. But this time around, what the attacker wants is, I'm going to use a different color. The attacker could open a port here on their own machine, and they're going to send a payload that automatically runs on the terminal of server, and server then immediately creates a tunnel. You see that it creates a tunnel, and then because you guys learned redirection, right? In 372, you guys remember that you can run a command, pipe it into whatever, right? So in this case, we can pipe it into our tunnel, right? So it's basically kind of made up of two things. We have, we do the attack, we deliver the tunnel over here, and then some command. So in this case, you could do something, I mean, this can be a lot of things, but you can create a file, let's call it secret.txt, right? Doesn't have to be an encrypted, it doesn't have to be root own or anything. Don't worry about access control for this. Just something in the seed account. And then basically then you can do cat, right? So if you do cat and pipe it into the tunnel, the data will be sent, and then you should receive it on this side and see the output. Is this clear enough? That should be it. So that's literally the whole thing, right? And so all we're gonna do is so that's the scenario. So in this case, I need to see the output on the attacker machine that you need to show, okay, the secret is here, this is the content, and then I ran the attack by sending the packet, a tunnel was built, and the data was sent to attacker, and here it is. Got it? All right, so the code for that one, pretty simple, pretty similar. So I'm just gonna CP the file, so I don't need to redo it. So I'm just gonna CP TCP session hijack. This is TCP. Let's just say session hijack. But this is going to be redirect send file or something. Right, send some data from the computer that you've stolen. Okay. So now we have. So let me. You guys are seeing the VM. Okay, so now ls nano okay, and it's going to be the same idea, right? So we have this is a still, we just first of all we need to steal the session, so we need the source destination, we need the source port and destination port, the correct flags, and the sequence and ACK numbers corresponding to that connection. So that's the same. This is going to change a little bit, right? Yeah. So you might want to think about what you need. So just like I showed before, let's say cat secret.txt redirect. You guys see that? So you literally just want to run this. And then, of course, you need to create the listening port on the attacker machine. So you can just use, as we saw in the PDF, we can just use the dev devices in the folder, right? And then create a TCP connection. So then put in the IP where you want to go, right? So in this case, it would be, which IP would go here? The attacker machine, exactly. So wherever, not destination, nope, it's actually the IP of the attacker. So think about this. So if I go back to the whiteboard, what's the goal? See, the connection is between client and server. Those are the destination and source, but the file is being sent to attacker. Yes, good. All right. So that's what you need to specify there. So I'll just put attacker IP to make it a little bit clearer, I guess. Okay. And then over here, you can just set up a port number, port 9090. Basically, that's where you want to connect to. Does this make sense? All right. Now remember on the attacker, then we saw in the PDF netcat-lv 9090, right? So that's the only, don't forget that part. Maybe I'll write over here. Don't forget to open listening port on attacker so that it can receive the file. So that command should be something like nc, which is netcat listen-lv, I think, or listen verbose, I think it means, and then 9090. So that machine is going to be listening on port 9090, and then you are going to connect to that. All right, and that should be it. As you can see, it's pretty straightforward. But the trick is to play around with these. Questions? Nope, pretty clear. Okay, so let's save this one. All right. We talked about that. And then your output, of course, you need, as I said, you need to show when you run the attack on the terminal of the attacker that you get the actual data. Okay. All right. So put in something in the file that, put your name or something in the secret file. Don't forget to always include Wireshark. That's actually should be useful. Okay, and then we're just going to now look at the last one, so we have some time. So let's look at problem number 3, which should be similar. All right, so this is going to be our creating a reverse shell. And that, as I said, would be the ultimate objective of a hacker is obtaining their own session. So because this time around, you will be able to now type more commands on the system. Okay, there's a question. Okay. All right, so let's go back here. All right, so now we're going to think about the last problem. So I'm going to go back to the whiteboard. This is problem 3 that I want you guys to implement. All right, so problem 3. Okay, here we are. Problem 3 is a reverse shell, right? So what that means, once again, you have a client and a server. There is an established telnet connection already, a TCP 3-way handshake already happened. Now the attacker needs to do the same, right? They need to send a packet. They need to send a packet over here. And this time around, the server, once again, creates a tunnel. So a tunnel will be created once again from the server to the attacker. But this tunnel now can send data in both directions. And so if you remember what we were doing, right, in the pipe, there's the construction of a tunnel, but now it's a tunnel that goes in 2 directions. And also, instead of sending a file, we actually send bash itself, okay? So we're going to send bash itself so that we can actually link the tunnel. And so now on the terminal of the attacker, this is a terminal of the attacker will get some, well, actually, you'll get probably a $, right? And then here, then now you can type all the commands that you want. You'll get output. You type another command, and you'll get output. And you can basically run it as if you had done an SSH or telnet. Is this clear enough? Yeah. So what do you guys think about it being a root shell versus a non-root shell? Do you think you could get it to be a root shell? How? I mean, think of, Well, you're just grabbing the actual batch. So you're just grabbing, you can grab whatever you want that you have permissions to. So it depends on the account, right? And what, what I recommend is try it out. See if you can think about this problem, okay? Can you get a root shell? Okay. Now remember this, because the payload is encrypted, it would be very difficult for you to insert this. And that's why it's obviously not recommended that you manage things through telnet. Anybody that's managing things through telnet, they're going to be in serious trouble, right? If somebody can figure this out. So, but if somebody has, but think about it still as just an exercise. What are the implications of this bash, right? What kind of a terminal do you get? Okay. It's a self. We'll have a discussion about it. But I want you guys to try to think about it because it'll help you to think about what controls might be in place. Okay. So just think about it. It's a fun.
Do you want us to? Oh, sorry. Do you want us to come up with a script that could do this, or just how you would hypothetically do it?
I'm not asking you to do it. I'm only asking you to think about it. Try it if you want, but it's not required. You're not going to lose any points if you don't.
Okay.
All right. Okay. So let's think a little bit about this one, and we'll finish up with this. So this is creating a reverse shell using TCP Session High-jacking, right? So it's very similar to the other ones. So I'm not going to repeat most of that. And really, as you might imagine, all we have to worry about is the code. So let's go back to the terminal, the VM. All right, and now you can see, I'm just going to copy TCP SH. So I'm going to copy this one, and I'm going to call it TCP Session High-jacking, but this is reverse shell. Reverse. .py. Okay. So I've created this file. Now I'm going to do TCP reverse SH reverse shell. Okay, same idea here. Take this. You probably need that too. Yeah. So then, thank you. So then you establish your IP and your TCP, right? So again, same thing. You need to get these parameters from Wireshark, etc. Then after that, this of course will change now. And remember here also the same thing applies that I had said before. You need to press enter, right? Just sending it won't just be enough. So think about that one. This is also in your handout. I'm just going to make sure that you guys get the correct one. So basically, we're just taking bin bash. As it says, you make it interactive by doing the -i, then you redirect it. That's it. So you're linking, it's like you're linking this program, just like you would run it in the command line. Like if you type this in the command line, you get the interpreter, right, to type commands. Now you're just linking it to the tunnel. So in this case, we're gonna do dev, and then TCP, and then of course, once again, the attacker IP, and the port number is 9090, but the additional thing is that you need to make sure that you put in the parameters that allow the flow of data in both directions, right? Because you're going to send a command, but you want data back. Send a command, get data back. All right, and then just to do that, you literally can do it like this. So 2 greater than, and then &1, and then 0 in the other direction, and &1. Okay, you can see how it sends it back and forth, and that should do it, plus, of course, the enter character or something. But this should be the exact command that you need to type in, right? What's inside the double quotes, and that's it. That's the reverse shell that you try this. And then don't forget, again, the netcat command is up here, right? So this is on the attacker machine so that the connection is accepted. And that should give you a terminal. So you'll get a prompt on your screen. The question that I asked is, do you get a $sign or do you get a £sign? Because that tells you if it's your root or seed, right? And then think about how, could you get a root shell? How would that work? Okay. Could be as simple as be logged in as root. What happens if you're, if you're able to succeed there? So just think about it a little bit. And that should be the 3 problems. So that, that's, we're good on time. So that's it. These are, remember, there are 3 problems that you will work on. Problem 3, problem 2, problem 1. Before Python, actually, you guys should appreciate Python, but before, when I did this class before, many years ago, we used C, C++ for this same one. It was a little bit tougher because you had to code everything in C and kind of build the headers. You've seen Sniffix. So Sniffix was not, this is a lot easier now. Scapy has really improved over the years. All right, yeah. So that's basically the 3 problems. That concludes TCP session hijacking. So hopefully it makes sense. And then you guys just have to, again, show evidence that this, that you can do it. And then I know, so that's TCP session hijacking. Then I know there was a question from Urusa. Right. So Urusa, can you hear me? Yeah, so she's not there. All right, well, we can do this on Thursday, okay? So Urusa. Okay, so it seems like she's not there. But we can do this problem on Thursday, just remind me. And remember, please, the key thing that's important for me on Thursday is, for those of you that are working with the hardware, please come to class, grab your equipment. I'm going to give you that. Remember, we have exam next Tuesday, so either work on TCP session hijacking or whatever lab, but also make sure I'm giving you that time. And I want to see you work on the project, Okay, I want to see you that you've started to at least ask questions of what needs to be done. Is that clear enough, guys? All right, so I'm going to stop the recording now.